we are going to perform an experiment on installation of hybrid solar PV system. So already we discussed previous is an DC load and with an AC load. This is a grid connected solar PV system. Okay, so in this grid connected, you can see it written here, solar hybrid UPS. So this is connected to the grid. So how it is connected to the grid means there is a black color wire. Okay, so in this cable it is connected to the grid. So grid is the one input and you can see the solar panel at the output. Okay, so I am taking around 200 watt solar panel and they are connected in series, and one is connected to the positive end of the solar panel and one is connected to the negative end of the solar hybrid UPS. So it can take two inputs. One input is from the solar panel and another input is from the EB. So now we have to connect this load. So how to connect the load is, so we have to connect the voltmeter in parallel. So at phase I had taken the neutral, I had connected the voltmeter. So from the phase I had taken to one connection to the same connection. So one connection to the ammeter and output of the ammeter to UPF wattmeter and output of the wattmeter to AC load. Here I am taking an AC load is 60 watts. Okay, so here I am not adjusting the load, a fixed load I am taking. Okay, so from the phase I taken, I connected the voltmeter in directly parallel. From the phase I taken, I had connected to the input of the ammeter and output of the ammeter is connected to the M. M is nothing but main. So output of the ammeter I had connected to the main M. Okay, and M and C are short circuited. So here the power factor is a resistive load. Here I am taking a wattmeter which is nothing but UPF wattmeter. So here you can see here M and C are short circuited. So input is coming to the M and M and C is short circuited, and you can see here the current will flow in the current coil from the output of L. So from the L you can see here this is the L. L is nothing but load and connected to the load. So this is nothing but to the bulb. Okay, next output of the bulb is connected, I mean the pressure coil and the bulb is connected to the negative. So the negative is connected to the pressure coil and the pressure coil is connected to the neutral. Okay, so this is how I am connecting the voltmeter, I am connecting the ammeter and an UPF wattmeter, and I am connecting to a DC load. Okay, so now this inverter is called as solar hybrid inverter. This inverter is connected to the grid also. So now this inverter can, for example, it is generating more power. This can export the power to the department using net meter. If you want extra power, we can import the power from the department by using an net meter. So this is of a small size, but what we have in your campus is 300 kilowatt. This is only 1 kilowatt. If it is a bigger size, that is called as a 300 kilowatt grid connected inverter. But there we don't have the battery, but here you have the battery. So battery, this inverter or this load will run for 24 hours, morning as well as in night. So 24/7 will get uninterruptible power. So this is what the importance of this experiment. Okay, so now hope you understood the experiment. So voltmeter connected in parallel, ammeter, wattmeter and load are connected in series as per the circuit diagram provided. I think this is very simple for an electrical student to understand how to connect an ammeter, wattmeter and load. The load is nothing but a resistive load. Since it's a resistive load, the power factor will be unity power factor. The maximum current, how much will flow? So what is the formula? How much amount of current will flow? So what is the power rating? So power rating of this bulb is 60 divided by 230 into cos phi. So 0.85, approximately some 0.5 ampere current only will flow maximum. So but we had kept a current of up to maximum of 5 ampere. Why? Because the manufacture only for 2.5 ampere or 5 ampere. Okay, so I think you know this basic connection diagram. So the current rating is 10 amperes I am taking, B1 E2. So I have been shorted B1 E2. So the current is 10 ampere and the voltage is 300 volts is nothing but 300. The scaling factor is into 4, available value into 4. So here the base scale is 2.5, upper scale is 5 ampere. So maximum current you can flow is 2.5 to 5 amperes. I had connected to 5 amperes. How to convert a lower scale to upper scale? Multiplying. So how to convert 2.5 scale into 5 scale? By multiplying 2 times. That's why into 2. So when you come to this voltmeter, the lower scale is of 150, upper scale is of 300. How to convert 150 scale into 300 scale? By multiplying with into 2. So now we will try to turn on. So now we have been given the EB. So this is nothing but EB. So we have been given the grid power, and we have been given the solar power. How many inputs are there? One is from solar. So we have been connected a 200 watt panel. So positive and negative are connected to the grid connected inverter, and solar input is given and grid power is also given. Both it will hybridize and everything is there in this board, and output of this we are connected to an load. So how we connected the load? We can see this right on the power readings. So how much voltage it is supplying? 120 into 2. Serial number 1, voltage is 120 into 2. Current is 0.15 into 2. Power is 10 into 4. Sorry, 15 into 4. 15 into 4. 15 into 4 is how much? 60 watts. The same is also consuming 60 watts. So this is how to connect the installation of an hybrid solar PV system. This you can buy at your house. You can go to online or you can design this hybrid solar inverter, and you can directly, by using your basic analysis, you can connect the solar panel, you can connect to the grid, and you can connect to an battery. This bulb will never stop. If there is a lighting or there is a night time or the morning time, independent, this bulb will be 24 hours will be working nature. So you can use this system in a hill, for example Himalaya, somewhere where you don't have the power, or somewhere location where you don't have the power. If you use this setup, you can run this AC load 24 hours without any interruption in morning and night. So if power is available, if power is not available, solar is available, solar is not available, but this bulb will be 24 hours working in nature. This is how that is the importance of this design. This is how to design a solar PV system where you can run a load for how many hours? 24 hours. So previous experiment also we had done, but it will run only with DC load. DC load is very costly, but AC load is very cheap. You can directly run the load as per your requirement. Okay, so this is how we connect different types of loads. Since for an example, since lighting is very important, I had connected a lighting load. Why? Because for poor people, those are in village, they want lighting at night time. So I had used an example of lighting load. You can connect an AC fan, or you can connect an AC charger, whatever the load you want. Okay, so this is how a charge controller, the hybrid, it's the same. In this hybrid inverter also, what are the components you have? Charge controller, MPPT. Since solar input is there, you have charge controller, MPPT, as well as hybrid solar. This is also connected to the grid. So this can export the power and this can import the power as per the requirement. That's why this is called a solar hybrid inverter. So actually you should not call this inverter. Why? Because it has to perform two modes again, grid connected inverters. So those are little bit separate inverters what we have in the campus. So those are little bit different category. This like a hybrid. Hybrid means what? We are giving solar input and we are giving the power. So solar you are given and electricity also will given. How it will charge? How the battery will charge? By taking solar or electricity? First it will take only solar. Morning time 100% will take use of the solar and it will make the battery to 100% full. So which power it will supply to the load is only from the battery. Why? Because battery is full. So at night time what will happen? Solar is not available, but the load is higher. Then it will take the power from the EB and it will try to charge the battery. From output of the battery can have an continuous load. So this is how to glow a bulb 24 hours without by using a minimum equipment. So this is how to give the connections of an solar hybrid inverter. Okay, so we are not going in depth, we are not dismantling this. Why? Because this is a different concept. We have to, in order to understand or to design this, we have to study from higher education to design this system. So this like we are studying only the basics of solar PV installation, just like how to interconnect the components, how to interconnect each individual components and make it to run. So hope the experiment is very clear. So here you will not get more readings. Why? The load is fixed, since you will get only one reading. One is voltage reading, ammeter reading and wattmeter reading. So just by that you can understand how it performs. If you want multiple readings, you remove the load and keep an variable rheostat, then you can perform as per the requirement. So this is all about which type of experiment to install. We have been already installed this and analyze the hybrid solar power inverter interconnected with which load? AC load and which panel? Solar panel and then grid connected system. So this is all about the experiment.